Hello everyone, I'm Zach. Today I will introduce a source generator for the strongly tapped ID in Entity Framework Core. As we know, in the principle of DDD, that is domain-driven design, the strongly tapped ID is an important concept. It can help us to make our code more business logical and can enable the compiler help us to prevent some compilation errors. For example, many people define the identity of an entity type as generic types like long, integer, or GUID. For example, I will define a person entity, and the identity is a long value, and name, and there is another entity type like product, long, or something like that. The ID type of person and product are all long. So maybe I can define a method called find by ID. Do you know what I will find by ID, or maybe something like remove by ID? Remove by ID. Do you know which I will remove, product or person? Right? You do know. Maybe I should add comments to it to explain what it will removed. This is the first problem. We can't tell what object to remove only by the method name and by the parameter type. The other problem is maybe I get a person ID, blah blah blah, and I get another product ID, and I will, maybe this is remove a person, and I intended to remove this person, and it should something like that, right? But I wrongly passed this variable to this method, so this method will have maybe the exception will throw at this method, and it says, oh, I can't find a person which of which the product ID is the person ID is this value, because I passed the wrong value to this method, because this method is used for remove person instead of product. But at the compile time, the compiler cannot tell I passed the variable incorrectly, right? Because all the ID, the type of ID are long. Using the strongly typed ID, we can define custom type for identity type. Like we can define, I will copy, paste, and I will define class person ID. And there is a long value property in the person ID type set, and product ID. And I will change the long into person ID. And this is called the strongly typed ID. What's the benefits of it? Let's take an example. The remove by ID, and the parameter type is person ID. So I can tell what will be removed by this method. Oh, it will remove person because the parameter type is person ID instead of product ID. Okay, so we do not need to add a comment to explain what the intention of this method, but we can tell from the parameter type, right? And another benefit is if I got product ID and got another person ID, and if I pass P2 to this method, it works, right? But if I pass the product ID to this method, and the compiler will tell us, oh, there's something wrong. You can't pass a product ID to this method. Okay? So the strongly typed ID can make our code more logically clear and enable the compiler to detect errors in compile time, right? In .NET 6, it's harder to implement the strongly typed ID. But since .NET 7, the Entity Framework Core has built-in support of strongly typed ID, and you can find the documentation from the MSDN or from the .NET Core's documentation in the what's new in EF Core 7, and in the which part, value generation is the value generation for DDD guarded types. In this section, Microsoft explained how to use the strongly typed ID in Entity Framework Core. But the document tell us the strongly typed ID will add more code complexity, so it worth considering before using the strongly typed ID, because we have to write a lot of extra code to enable the use of strongly typed ID. For each strongly typed ID, we have to write about 100 lines of code to enable one strongly typed ID. To make it perfect, the Microsoft give a simple example about the implementation of strongly typed ID, but the sample code is not enough. We have add more code, like the operator overloading and the value generator and something like that. So for each strongly typed ID, we have to write about 100 lines code. So a lot of verbose code to write. So I created an open source project to help you to write those verbose code. Using the source generator technology, you just need to add just one line of code. Just add a attribute that has a strongly typed ID, this attribute, to the entity type, and use the person ID or the entity name plus ID as the strongly typed ID. All the extra code generated will be generated by my source generator, so it's easy to use. Let me explain it to you how to use it. You can visit my GitHub page. My username is YANGCHONGKE. It's a Chinese name. Maybe it's hard for you to spell, but it's YANGCHONGKE. And this is the repository of this project. letscode.efcore.stronglytypedid. I have explained how to use it in the README, so you can check the README documentation to help you how to use it, and I will show you a little bit about how to use it in a single project. As we know, in a real-world project, we usually put different classes in different projects. Like we put entity types in a module project, and we put the DB context or repository in repositories or in the other project, and we put the UI code in the WinForm or ASP.NET Core project. But to make it simple, I will introduce how to use it in a single console application, and my documentation explain how to use it in multi-layer project. So you can check it how to use it in the multi-layer project, like in the 1, 2, 3. This point, there are 4 packages to be installed in the project where entity types resides, and install this package to the project where something DB context resides. Okay, but I will introduce it to you how to use it in a single project, and I think it's easy for you to split them into multi-project. Okay, first I will create a .NET 7 console application. .NET 7 create. And first I will create the entity type person. And first I will install the Microsoft Entity Framework Core into the project where entity types resides. In theory, the Entity Framework Core NuGet package should not be installed into the project where entity classes resides, because we should not assume that our project should use entity framework. Maybe we can use the entity type in other ORM framework, but due to the limitation of source generator technology, you must to install this package to the project where entity classes reside. Okay, it's a trade-off. First, install it. Second, install the letscode EF-core strongly typed ID generator. And last, install the last ifcall.strongly typed ID comments. And then I can define the public ID is person ID. Okay, because the compiler will generate a class named person ID as the strongly typed ID types. Okay. Oh, don't worry. The compiler will, the source generator will generate the code for us. So do not worry about it. Do not worry about the Visual Studio's error message. Okay. First I will put this attribute. This has a strongly typed ID. Put it, and you can see the person ID is highlighted because when I put this attribute to this class, and the source generator, my source generator will run and generate the person ID for you. So when the source generator saw a class with this attribute, it will create a type. The name is entity type plus ID. Okay, so you can use the person ID, and you can control and click this type. This is the code I generated for you. You cannot see this type in the Solution Explorer because it's generated in compile time. You can't see it in the source code, but you can control left click this type and see the code generated. It's near about 40 lines of code. I do all this for you, don't worry. And as you can see, the generated code about toString get hash code equals and something like that. And then public string name, just one line of code. And then I will define the DB context, my DB context, over module creating. And because I will use Circle Server to run this application, and I should install the ifcall Circle Server a NuGet package and install because I will use the DB migration, and I will install the ifcall tools NuGet package. I will search it, NuGet entity framework call Circle Server. And tools is for the DB migration. Okay. Then module. Oh, sorry. Which method? On configuration. On configuration, use Circle Server. I will copy the connection string. Example 10. And I will copy this module builder Before that, I will install this NuGet package, letscode.efcall. In this NuGet package, I define two important methods. These two important methods, so I have to install this NuGet package, and I will put unmodel creating and override the convention override config convention and copy this line. Okay, you just need to configure it once, and all the entities with the attribute will have the ability to use the strongly typed ID features. Okay, and then let's try it. Before that, I will execute the DB migration to create the database. Add migration. Oh, what's wrong with it? So let's have sorry, I forgot to add the DB set. DB set persons set, and execute the migration again. Okay, done, and update database. Okay. Oh, as can be seen, the persons table has been created. Okay, and because the default data type for the ID is long, so the ID column in the database is big int. And if you want to use other type, like if you want to use the GUID, and you can specify it as GUID, right? And the default value is long. Okay. And you can use customized type, like something. Okay. If XXX is your custom data type, you can use it like that. Okay, so commonly used is long and GUID. Okay, and then I will try it using my DB context. DB context. And new person. The ID is auto-generated, so I just to specify the name and DB context. And DB context dot save changes, and I can print out the auto-generated value dot ID, and I can print it out. Okay, done. Right, and then we can try other features like we can db context dot persons dot single p dot id new person id 1 p dot name. This is the comparison between two person IDs. Right? And that's all. Okay, this is the usage of person ID. Like we can extract the code into a method, person find by ID, person ID, return p. Find by ID, new person ID. Dot name. Okay. Cool. We can check the decompiled code. You can see the person ID is generated strongly typed ID class. It can include the value, the toString, and the equals, get hash code, and the operator like the greater than, less than, equals, like that, and the value converter class are always generated either. And this method is used for the load the value converter into the EF core conventions. Okay. Hope this library can help you. If you have any suggestions or some bugs to report, welcome to create an issue in my GitHub page. Thank you, and if it helps you, welcome to share it in your technology community. Thank you. See you.